Okay, today we're on pages 162 and 163. You want to have your calculator and a whole lot of patience and perseverance here. So, mortgage payments. Mortgages are large amounts of money borrowed from a bank called the principal, also known as simply the mortgage, or mortgage amount. Monthly mortgage payments can be calculated using the formula below. The formula comes from a geometric series, but we'll just be learning how to work with the formula to solve for different variables. So yeah, this is a complicated formula. You do not have to memorize it. If you see a question involving mortgages on the Regents exam, they usually provide you with the formula or a variation of this formula. Okay, so the capital M is the monthly payment. It's similar to like rent, all right, but you're paying towards the amount you borrowed. So capital M is the monthly payment, P is the amount borrowed, which is the principal, also known as the mortgage amount, R is the annual interest rate, and N is the number of monthly payments. So we don't have time here, we have time in the form of the number of monthly payments. So M equals P times R divided by 12 times 1 plus R divided by 12 to the N, all divided by 1 plus R divided by 12 to the N, subtract 1. The most basic way to use the formula is to calculate monthly payments. You took out a 30-year mortgage. Well, 30 years, how many months is that? 30 times 12, that is 360 months. So that is N. So N is 360. For $220,000 to buy a house, so the $220,000 is your capital P. The interest rate of the mortgage is 5.2%, so your R value is 0.052. What are your monthly payments? So we're trying to calculate capital M, our monthly payments. So M equals, and we are simply making substitutions into that formula. So 220,000 goes in for P. R is 0.052. Again, we're just replacing the values here. R 0.052. N is 360. And into the calculator. Again, please, you're doing the same. You're not just watching, you're keying this into your own calculator. Okay, I think that looks good. So $1,208 and to near a cent and 4 cents. So the monthly payment would be $1,208.04. When you're taking out a mortgage, you often know how much you can afford each month. You want to determine what size mortgage you can afford, meaning we want to, what's the amount of the loan that you can take out, the principal. Based on your current income, you can afford mortgage payments of $900 a month, so that is our capital M. You also want to take out a 15-year mortgage, so that would mean that N is equal to 15 times 12. That's 15 times 12, 180. And the interest rate is 3.4%, so R is equal to 0.034. What size mortgage? So what principal can, so we need to solve for P, all right? So instead of plugging into the formula, all right, I want to take this and get P by itself first, okay? So I'm going to write down, use a different color, M equals P times R divided by 12, 1 plus R divided by 12 raised to the n, all over 1 plus R divided by 12 to the n minus 1. Okay, so we want to get P by itself. We want this by itself. Alright, so I'm going to put this over 1 and think about like cross multiplying. So P times R divided by 12 times 1 plus R divided by 12 to the n times 1. So this is cross multiply. Cross products are equal. It's a proportion. So we have M times this. M times this. Okay, so now just one more step and we'll have P by itself. We just divide here. It's just going to get messy, so I'm not going to show the work. So it's going to say P is going to equal this divided by that. Okay, so now I have the formula solved for P. Now let's make our substitutions. M was 900. R is 0.034. N is 180. Calculator. $126,763.80. The last way we'll learn to use the mortgage payment formula involves determining the length of the loan that you can afford given the cost of a house, the amount you can spend per month, and the interest rate. So imagine you found the house of your dreams for $330,000, that is P. You know you can afford monthly mortgage payments of $1,500, that is M. You qualify for a mortgage with an interest rate of 4%, that's R. Algebraically determine the number of payments, that is N, the number of monthly payments you would need to make to pay off the loan at this rate to the nearest whole number. Okay, so we want to solve for n. So I'm going to take this here, this line right here, and we're going to solve this for n. So the first thing I'm going to do is distribute m, because we have n in two locations. We have it here as an exponent and here as an exponent. So right now this is being multiplied by m, so let's do that. I'm just copying the left-hand side here. So this is going to be m times 1 plus r divided by 12 to the n minus m times negative 1 is m. Now, I want to get my terms that have the exponent n on the same side. So I'm going to subtract this, and again, I'm not showing the work because it will just get too messy. So I'm subtracting m times 1 plus r divided by 12 to the n from both sides. So minus m times 1 plus r divided by 12 to the n equals negative m. Okay, so now factor out this 1 plus r divided by 12 to the n, because that's common to this term and this term. So that comes out. So we have 1 plus r divided by 12 to the n times p times r divided by 12 minus m. Right, so this came out of each term here, so you're left with this minus m. Okay, we're getting closer. All right, we have this times this, so undo this multiplication, divide. 1 plus r divided by 12 raised to the n equals negative m divided by p times r divided by 12 minus m. All right, well, what do we have from last unit? We've got our base and exponent isolated finally. So now we switch to log form. So this is log base 1 plus r divided by 12 of this fraction, which is negative m over p times r divided by 12 minus m. That equals n. So finally we have n by itself. Now we'll make the substitutions. Log base 1 plus 0.04 divided by 12 of negative 1500. P is 330,000. 0.04 divided by 12 minus 1500. Calculator. Alpha window number 5. So this is 397 something. This is all equal to n. to the nearest tenth, no, to the nearest whole number would be 397. And so that's the first part. That's the number of payments, 397 payments. And how many years would it take you to the nearest tenth of a year? Oh, 397 payments, or 397 months, divide that by 12. It's approximately 33.1 years. So that answers our second part. All right, and just to show you, so you're making payments of $1,500 a month and 397 payments. So this is how much you're actually paying back. So on that $330,000 loan or principal that you took out, this is how much you're paying back. So there's a lot of interest in there. So if I just take that amount and minus the principal, you're paying like $265,000 in interest. And this is realistic. Okay, on the next page, we've got another variation to the formula. Here we have Andy has a $200,000 mortgage at 4% yearly interest. He's paying off his mortgage with $1,600 monthly payments, much of which is initially going to interest. That is true. How much he still owes after end payments is calculated with the following formula, where M is the monthly payment, R is the monthly interest rate, P is the principal, and N is the number of payments. Find the amount owed on this loan after 1 year and then after 10 years. Okay, so R is a monthly rate, so R here is not being divided by 12 when it should be. So our monthly is yearly divided by 12. Sorry. Okay, so 4% yearly. So in this case, we want 0.04 divided by 12 to replace our R. We want yearly divided by 12 is monthly. And the mortgage, so this is M, and this is P. And what's N? Find the amount owed on this loan after 1 year. So this is the amount owed. All right, so substituting in. One year. For 1 year, N is going to be 12. I lost P. There it is. And you have to show the substitution into the formula. Again, patience and perseverance here. times 12. That takes care of our numerator and our denominator. Go to the calculator. I'm going to save just a little bit of time and tell you that it's $188,592.37. That's for the amount owed after 1 year. Then after 10 years, that would be an end value of 120. So the only thing that changes is in the calculator, you're changing all of the 12s and values of 12. No, sorry, not all of the 12s. Just the n here. And the n, oh, I missed that n. 1 plus r to the n. So this 12 and this 12 would be 120. Throw that into the calculator, save time. 62,566.85. Our next exercise, I tried to speed this up. I paid $297,000 for my house in December of 2008. The annual interest rate was 5.2%. This is an annual interest rate. All right, we call R as the monthly interest rate, so that would be 0.0425 divided by 12 would go in for R in this case. For 30 years, 30 times 12 is 360. Calculate the monthly payment M using this formula. Oh, a much simpler formula, very nice. So M is equal to the principal, 297,000 times R, 0.0425 divided by 12. Let's just put that in parentheses. All over 1 minus 1 plus 0.0425 over 12 raised to the negative 360. All right, throwing that into the calculator. $1,461.06. And finally, our last question, use the formula above, nice and much simpler one. Determine the number of months it would take to pay off a $150,000 loan at a monthly interest. Okay, so this is a monthly interest rate. So that's just our R value. So R is 0.005, right? Always changing the percent to the decimal. We want to find out the number of months, so we want to solve that for N. All right. So again, before substituting in, going to kind of just put this over 1 and cross multiply. So we have P times R is equal to M times 1 minus 1 plus r to the negative n. We could distribute the m if we wanted, or we could divide by m. It doesn't matter. If I distribute, and we want to get this base and exponent by itself, so next we subtract m. And now divide by negative m. Again, I'm not showing those steps because it just get a little too messy. So we have p times r minus m divided by negative m equals 1 plus r to the negative n. Okay. Switching to log form. Log base 1 plus r of p times r minus m divided by negative m equals negative n. Right. I don't like the negative, so multiply both sides by negative 1, and we have negative log, and in the same step I'm going to substitute in our values. P is 1,500. Calculator. I apologize, this is so long. So n equals to the nearest, how many? 278. Monthly payments. And we've gone well over time, so we are not going to do B. Thank you for hanging in there with me. Bye-bye.